Good morning, young people. It's Mrs. Rains. Just getting ready to talk to you a little bit about significant figures. So here we go. So first of all, I want to talk about implied range of uncertainty. You have an implied range of uncertainty in a measurement, and it can be reported as just like 5 centimeters or something like that. When you report this measurement as 5 centimeters, it implies you have 1 centimeter to either side because you're saying your uncertainty point is the 1 centimeter mark. Okay? If you say it's 5.0 centimeters, then you're implying that you have 0.1 centimeters. That means, on either side, that you're certain about the 5, but you're not certain about the other. And then if you apply it as 5.00, notice your range of uncertainty is going down. Now, for this particular ruler, your answer should be 5.00 centimeters. As you can see, when you don't report your number correctly, you're implying more uncertainty into your number. So you need to make sure that you tell us what the uncertainty range is by recording the number correctly. So we talked about that a little in class, and I wanted to make sure that we mentioned that as well today. So rules for counting significant figures. I'm going to mention the rules, and then I'm going to show them to you. So we're going to go over this part quickly, and then I'm going to show you each of the rules as we go. Non-zero integers always count as significant figures. We've talked about that. 1, 2, 3, 4, 5, 6, 7, 8, or 9 is always significant. Zeros. This is where things get crazy because there are actually 3 classes of zeros that we can talk about, and there are rules for each of the classes, and as a matter of fact, one of the class has 2 rules. So the first class of zeros are leading zeros. That means zeros that precede any non-zero digits, and they don't count as significant. So what you can see here is these 3 zeros right here are considered leading zeros. These zeros are holding place. They're just placeholders. This 0 is not even necessary, and these 2 zeros are just holding place. So in fact, this only has 2 significant figures. Captive zeros. Captive zeros are zeros between 2 non-zero numbers. Anytime you have a captive zero, it's certain, and therefore it was measured, and it is significant. So here you see these 2 zeros right here between the 1 and the 8. The 1 and the 8 bookend the zeros. Therefore, we have 4 significant figures there because we have captured zeros. Trailing zeros. Now, this is where we get a little crazy because there are 2 kinds of trailing zeros. Trailing zeros are zeros at the right of the number. Now, depending on whether you have a decimal point or not, trailing zeros are considered different. So let's look. Trailing zeros are significant if the number contains a decimal point. So if we look at that, 1.00 times 10 to the second, because there's a decimal point, those zeros are considered significant. They have been counted. This last 0 is my uncertain spot, and these are my certain spots right here, this 1 and the 0. Therefore, we have 3 significant figures. However, if you have trailing zeros that do not have a decimal point. For example, 100, no decimal point. That assumes that that 1 in the 100 spot was your uncertain point. And so that means there's only 1 significant figure. So trailing zeros with decimal points are significant. Trailing zeros with no decimal point are not significant. That is probably the most confusing zero issue we have. Leading zeros are never, ever counted as significant figures. Zeros that are bookended by 2 significant numbers are always significant. Trailing zeros, if there's a decimal point, they count. If there's not a decimal point, they don't. Exact numbers is the 3rd major rule. And this is basically when you have conversion factors, like 1 inch is equal to 2.54 centimeters. They should never, ever limit significant figures. As a matter of fact, they are considered to have infinite significant figures, so they don't ever limit calculations when we do them. So let's look at Rule 1. Rule 1 says any number that is not 0 is significant. So in this case, all 3 of these have 3 significant figures, 2, 4, and 7, 7, 4, and 3, and 7, 1, and 4. All of them have 3. Notice that 0 that is not even necessary, it's not counted because it's a leading 0 as well. So every non-zero digit reported is considered significant. Okay. Next one is Rule 2A. So this is talking about the leading zeros. Leading zeros are not counted as significant. So We have 7, 1 is significant, 4, 2 is significant, and the 9, 9 are the significant. But these zeros here are not significant. Now, a lot of times when you see things typed, they leave a space to mean a comma. That is very common. So these have 2 significant figures for each of them because the zeros don't count. So rules. Leftmost zeros appearing in front of non-zero digits, that's leading zeros, are not significant. Writing them in scientific notation helps. So if you actually write these numbers in scientific notation, it gets rid of leading zeros. As a matter of fact, scientific notation gets rid of leading zeros and trailing zeros with no decimal, and it makes things a lot easier. But for another time, actually a little bit later. Rule 2B. Rule 2B says anything that's captured is significant. So we've got a 7 bookending these 2 zeros, they're captured. We've got a 0 being bookended by the 4 and the 7, it's being captured. We've got a 0 being bookended by a 5 and a 3, it's being captured. So every single one of these has 4 significant figures. So what's the rule? Zeros appearing between, or sandwiched zeros, between non-zero digits are significant. So we're talking about sandwiched zeros or captured zeros. Okay. 2CI, this is the one about trailing zeros. Remember, 2C is about trailing, and we have 2 different rules here. So zeros that have a decimal point trailing are significant. So here we have a decimal point, so these 2 zeros are significant. Here we have a decimal point. This one is captured, but this one is trailing, and it's significant. Here we have a decimal point. These 3 numbers are significant. We're implying that we've measured these 2 with marks, and that this one has been guessed. So that's the implication there. So how many significant figures do we have? In all, we have 4 significant figures. The rule is zeros at the end of a number and to the right of a decimal, trailing zeros with a decimal, are always significant, always. Okay, the next rule with trailing zeros, 2C with trailing zeros, is that anything that does not have a decimal point, the trailing zeros don't count. So do you see a decimal point anywhere in here? You don't see it. It is implied because we know that that's 300, but there is no decimal point, so therefore we cannot count the zeros. So these guys have 1 significant figure. The 3 is significant, the 7 is significant, and the 4. What's the rule? Zeros at the rightmost end of the measurement that lie to the left of an understood decimal point. That means without a decimal, basically. It's understood because we know it exists, but it's not listed, so that's why it's called understood. They are not significant. They are only placeholders, and they're only telling magnitude. Again, scientific notation would be a good thing here. Anytime you have placeholder zeros, scientific notation really helps you take care of that. Okay, rule 3, counted numbers like 12 students. That's not considered significant in the traditional sense. Exact conversions like 1 meter is equal to 100 centimeters. 1 in any conversion, like 1 inch is equal to 2.54 centimeters. These are considered exact. And so exact numbers do not limit the number of significant figures in any answer. And they have an infinite number of significant figures. So these will never, ever determine sig figs in a calculation. Anytime you use a conversion factor or a counted number, 1 student per classroom or 30 students per classroom, those are kind of considered infinite, and we don't want those to limit our calculations. So significant figures and counting them. Count all numbers except non-sandwiched leading zeros and trailing zeros without a decimal point. So if we had to boil this down, you're going to count everything except non-sandwiched leading zeros, so zeros that aren't sandwiched between numbers that are leading aren't going to get counted, and trailing zeros without a decimal point are not going to get counted. So if you had to boil it down to 2 things, those are the 2 things that I'd probably boil it down to as simply as possible. Okay, significant figures indicate precision of a measurement. So significant figures, we're trying to figure out how well we're doing in our measuring. So recording sig figs, we must know the digits plus a final estimated digit. We already know this. So if we look at this paper clip and we look at it on the ruler here, we want to know the length of the paper clip. So we look and we eye it out. Oh, we see it's definitely 2, so it's between the 2nd and the 3rd mark. We know that's 2. We have smaller marks, the 0.1 marks, and we know it's between the 3rd and 4th mark, so it's 2.3. And now we have to eye this number. It's not exactly on the 4th mark or near the 4th mark. It's a little bit away. So I this at 2.38. Again, if you said 2.39 or if you said 2.37, those would be acceptable as well. Okay, so remember, certain digits with marks have to be included. There must be one estimated or uncertain digit. So here we go. Counting significant figures. So we have 23.5. Let's see. These are the significant digits, right? They're all significant, so we have 4 significant figures. Here we go, 402. Oh, they're all significant too because we have sandwich zeros, so that's 3. How about this one, 5,280? What is it missing? It's missing a decimal point, so this 0 is not significant. So only the 5, the 2, and the 8 are significant, so we have 3 significant figures. In this figure, we've got a couple kinds of zeros, right? We have a trailing 0, but it has a decimal point, so that trailing 0 counts. We have leading zeros, but they're not sandwiched, so these zeros don't count. So we have the 8 and the 0, and that would be 2 significant figures. Okay, rules for zeros, again, leading zeros, if they're leading zeros, they don't count. Okay, so we have 3 significant figures here. Captive zeros. Captive zeros do count. They are significant, so we have 4 significant figures here. Trailing zeros, we've got 2 kinds of trailing zeros. So we have trailing zeros with decimals, and they all count, 5 significant figures. And then we have trailing zeros with no decimals, and they are not significant. So we only have 3. Oops, that's wrong. That should be 3. Sorry about that, guys. Made a mistake and didn't change something. Okay, pen, I'm going to cross that out. That should be 3. Oops, it's not doing it. Hang on. Let me see if I can get it to do it again. 3. That should be 3, not 5. Sorry about that. Okay, calculating with Sig Figs. We've got to remember that when we're calculating with Sig Figs that we have to think about what we're doing. Multiplication and division is dead easy. Basically, we count the number of Sig Figs in all of the parts of the problem. The one with the lowest number of Sig Figs determines how many Sig Figs I have in the answer. So let's look at a problem. We have 13.9 grams per centimeter cubed times 13.3 grams per centimeter cubed, or I'm sorry, centimeters cubed. So 13.91 grams per centimeters cubed times 23.3 centimeters cubed. We get an answer when we put on our calculator of 324.103 grams. So let's look. The first number has 4 significant figures. 1, 3, 9, 1 are all significant. The second number has 3 significant figures. 2, 3, 3 are all significant. So that means with 4 significant figures and 3 significant figures, I can only have an answer with 3 significant figures. So I've got to look at my answer, 324.103. I cut it off at 3, so I'm cutting it off right here at the, right there. That's where I'm cutting it off. The 1 doesn't make the 4 round up, so my answer is going to be 324 grams. Okay, so in multiplication division, always, it is the smallest number of Sig Figs. So the 3 determines the number of Sig Figs in this particular case because the 23.3 has 3 Sig Figs. Addition and subtraction is a little different because now we're talking about decimal place. And it gets a little confusing, but we have to line the decimal up. So if we look at this problem, we see that we've lined the decimal up and we come up with an answer of 7.85. Well, what's significant or what's not significant? The 5, the 1, and the 5 are the least significant place in each of those numbers, but we have to look at the one that has the least significant place. So we are going to be looking right here. The 10th place is the last common significant place for all of them. Because the 4.1 doesn't have a hundredths place, I can't count that. So that means I have to look at my number and it's 7.85. The 5 makes the 8 round up, so my answer is going to be 7.9 milliliters. Okay, let's do another problem. So we have 224 grams, 130 grams, notice no decimal point, and we get 354 grams. So no problem there adding. We've got it all set up. So now, where do we find it? Okay, the 4 is the last one, the 3 is the last place, and the 4 is the last place. So basically, we've found the last place because there it is. So our answer can only be 3, 5. The 4 doesn't make something round up. So we have 2 significant figures, so 350 grams. I'm going to stop right there, and I'm probably going to add another a little bit later. Thank you.